So on your, just kind of on your XNet machine, and don't log in now, kind of focus up on the screen, but I've created this little volatility shell, which will bring you right up to volatility, right? So if I were to run vol.py --info, slowly but surely, we'll get a list of all of that output, right? Everyone see that okay on the screen? But you'll see all the different plugins that are available, the different profiles. And this is a little bit more advanced stuff at the bottom, which we won't really cover here. But just to kind of be aware of when we're, this is basically where you can get a listing of like what options are available to me, right? So now I've created a little, demo memory image. So I'm going to set up this file. And again, I'm kind of using this syntax, right? We're going to specify the profile. In this case, it's WinXP Service Pack 3 x86. I want to make it clear that this the profile is case sensitive. It's looking for that exact string. So, the W needs to be capitalized, the XP, so on and so forth. We're then going to specify the file. And one cool thing about Windows is that you can do drag and drop. So I am going to grab this memory image. And you can see it automatically appends that full path there, which is nice, right? Saves me from having to type it in. And then I'm just going to, simple command, I'm just going to run pslist. And this is almost always where you're going to start because let's get a listing of processes that are on the system, right? So we run that, and it'll take a couple of seconds. But you'll see we get this list of processes that are on the system, right? And you can see that this is pretty similar for those of you who have seen task list output before. You can see that this is pretty similar to that, right? Basically process, the parent or the process ID, the parent process ID, some additional information such as threads and handles that are associated with it, and the time in which it was executed, right? If we were to look through this, right, we may not, immediately kind of be triggered to any like, oh, this is suspect, this is where the things are, this is where the badness is happening, right? But we can probably identify maybe some odd names or things like that to kind of start with. Anyone see anything that stands?
HFBCT.
Yeah, I would admit that that's probably a little bit different name, right? Don't know what it is, but we can find out. Go ahead.
This utility work with the physical memory dump, right? I can see right there. Does it work with the Hibernate files, or does it work with the page file? What utility does it?
Okay, so it only works with physical memory dump. So it's looking for a particular structure, which would be like what we created with WinDD yesterday. So I would argue that probably this name right here, you have this HF, BCT thing here, is probably, we don't know that it's bad, but that's a little bit of an interesting name. So we can do something like let's dump the address space for that process, right? So I'm going to hit the up arrow, right, which gets me my last command again. And I'm going to backspace out, and I'm going to run the memdump command. And memdump is going to dump process memory for the process that I'm interested in, which I need to specify by a process ID using the -p option. And you can see here, if we were to scroll over, this third column here is the process ID, which is 3696, right? So I type in 3696. And then I need to specify where I want to save that to using the -big-D command. And I'm going to put it on, let's see, I'm going to put in this, on the root of my G drive here. So everyone see that command, understand what we did here? We just, basically just identified the process ID and then the place where we want to save the dump to. And you can see that it's writing basically this output, this HFBCT, to a dump file, right? 3696.dump. And it'll take a few seconds, right, because it needs to identify the memory space that was used by that process and things like that, and actually write it out to a file. So this can take a couple of minutes sometimes. But there we go, right? And now if we were to look on the root of our G drive, you'll see that we have this about 80 meg process memory dump here, right? And if I were to open this up in my favorite hex editing tool, you'll see that we have, hopefully not all zeros, you'll see we actually have stuff in there, right? But you can see it's a lot of non-readable text, right? because there's a lot of like, DLLs are going to be used by that and so on and so forth. It's just regular memory space that's accessed by that's being accessed by processors and things like that. So what can we do here to actually see something that's a little bit more readable? Strings, right? We can run strings against that output. 3696. And what I'm going to do is I'm going to use the grep command because I'm going to filter my output a little bit. And I'm going to search for that name just to see where else I get hits for it, right? And I'm going to let that basically pipe out to the screen. And you'll see we get a couple of hits there, right? Some of it probably looks a little bit familiar, right? These lines here are very similar to what we saw in that taskless output. You see the console option there, or console session that's created there, right? But then at the bottom we also have, let me scroll up a little bit so you can see that a little bit better. We also have a path that's associated with that file, right? Now this isn't, we could have looked on the disk and we probably could have seen that file there, but maybe that file isn't there anymore, right? But now we know where it originally resided, right? We can get some information out about where it was at one point. So this can be useful for a couple of reasons, right? And you can see that it was very quick, very simple, but now we have another thing, that we can go look for, or another thing that we can now jot down and say, this is something I want to look at when I'm in my next stage of analysis.